Hello guys, today we're going to be talking about the product rule. So the product rule is one of the three big ways in calculus that you can find the derivative of a function. The three, to my knowledge, are the product rule, the quotient rule, and the chain rule. It's also I guess you can call it the power reduction rule, but that's kind of more of just a shortcut from the definition of derivatives. So first I'm going to start with the definition of the product rule, and then we can look at forms that would be the product rule and forms that would not be the product rule. So we're going to assume that we have a function p of x that will be equal to f of x times s of x. So to define some variables here, p of x will be our function that we're using product rule on. F of x and s of x will be our first and our second function. So f of x is our first function, and s of x is our second function. Also, if any point, if you guys get seriously irritated by not writing straight, I will try my hardest, but no promises, because this is a little bit tricky writing on whiteboards. So, product rule can only be done if it's the product of two different equations. So, if I wanted to show you what would be considered a product rule, so if you had y was equal to x plus 4 times x plus 7, that's a product rule. If you had y is equal to 7x plus 3 over x plus 4, this is not a product rule, this is quotient rule. And if you were to have something like 4x cubed times x squared, you can treat this as a product rule, but stuff like this, it's actually a lot simpler if you just simplify it down to 4x to the fifth, and then you can just do power reduction rule. So that's the general form that you see for things. And also one more, if you had y was equal to x plus 4 to the third, then this is actually chain rule. So if I were to write down the rules on these, this one is product rule, this one is quotient rule, this one you can use product rule, but you don't really need to, and then this one is chain rule. Also, all the notes I go over will be attached in the comments as a pinned comment with a link to Google Drive or anything like that. So my problems and my solutions and the questions I go over, they'll all be in the comment section if you check for it. You can also just use that and follow along if you want to, or you can write it down yourself, matter of preference. So the definition of the product rule, if I were to write it in words, it would be the derivative of the first function times the second function plus the derivative of the second function times the first function. So if I were to write that out in notation, we could say that the derivative of p with respect to x is equal to the derivative of the first function with respect to x times the second function, and then plus the derivative of the second function with respect to x plus times the first function. Or you could just say p prime is equal to f prime times the second function plus s prime times the first function. Either one, they're equivalent forms. You can use either one of those. So going into some examples. Our first question is going to be, there we go. First question is going to be y is equal to 2x plus 3 times 3x squared plus 2x cubed. So for starters, let's identify our first and our second functions. So 2x plus 3 is our first function. And 3x squared plus 2x cubed is our second function. So using that, we can just apply the product rule. So we can just say that the derivative of y with respect to x is equal to the derivative of the first function, which is 2. The derivative of a constant is 0, so it's 2 times the second function, 3x squared plus 2x cubed, plus the derivative of the second function is 6x plus 6x squared times the first function, which is 2x plus 3. And then I'll distribute out the 2 and I'll just leave it like that. It's really not much of a need to simplify past that. So we'd have 6x squared plus 4x cubed plus 6x plus 6x squared times 2x plus 3. And all of this divided one more time as the final answer, we write it as 6x squared plus 4x to the third plus 6x plus 6x squared times 2x plus 3. And this is our final answer. So we can check it. We identified our functions, so the first part is fine. We took the derivative of the first function multiplied by the second function. We took the derivative of the second function and multiplied it by the first function. We distribute out the 2. And then we kept this all the same, then we revoted. So this answer is correct. So that's question 1. In all these questions, I'm only going to be finding the first derivative, mostly just because it's a time restraint. So if I wanted to find the second derivative, you can just use power reduction rule on this first part. For this part, this is another product rule. So you can, it just takes a little bit longer. I can always do that in another video if you guys want. But that's question 1. So for question 2, we have y is equal to x cubed plus 3x times 2x squared plus 2x. So we can identify x cubed plus 3x as our first function. And we can also identify 2x squared plus 2x as our second function. So now that we know that, we can just take the derivative. So we can say that the derivative of y is equal to the derivative of the first function. So that's 3x squared plus 3 times the second function, which is 2x squared plus 2x, plus the derivative of the second function is 4x plus 2 times the first function, which is x cubed plus 3x. And I would just leave it here because you can multiply it out, but it'd take a little bit longer. So I would actually leave this one right here. Hopefully you guys wouldn't get a question this long. Hopefully you guys would get something more like y is equal to x plus 4 times 2x plus 5. Hopefully you guys would get something like that, because this one's a little bit easier, a little bit more straightforward. But if you guys got something longer like this, I would just leave it here because it's a little bit easier. So I can check this. So we identified our first and our second functions. We took the derivative of the first function, then we multiplied it by the second function, then we took the derivative of the second function, multiplied it by the first function. So this is right. I would just leave that there. It's a little bit easier if you're trying to find the second derivative. Because if you had to find the second or third derivative, if you multiplied it out, that would take you a couple of minutes. And then taking the second derivative, well, you have a double product rule. So you have a product rule here and a product rule here. So it'd take a little bit longer. So I would just leave that as my final answer. Usually it's always better to not have to do random acts of algebra to simplify it all the way down. So that's question 2. So for question 3, we have y is equal to sine of theta times cotangent of theta. Now you don't have to use product rule in this one. This one can actually be simplified down to just, so if you know that sine of theta times cotangent of theta, cotangent is cosine over sine. So it actually just becomes cosine of theta, and the derivative of cosine theta is negative sine theta. So that is one equivalent form getting the answer. But since this is product rule, I'm actually going to show you how you just use the product rule on it. So this is our first function. This one right here is our second function. So now that we've identified sine of theta and cotangent of theta as our first and second functions respectively, we can just go ahead and take the derivative of them. So the derivative of y is equal to the derivative of sine of theta, which is cosine theta, times the second function, which is cotangent theta, plus the derivative of cotangent theta is negative cosecant squared theta, times the first function, which is sine theta. So two things we can notice here. We can notice that cosecant theta is 1 over sine theta. So cosecant squared theta times sine theta is just going to be cosecant theta. Then if we go over here, we just keep this the same. You could, if you wanted to, you could rewrite it as cosine squared theta over sine theta, but that really wouldn't help you too much, because then you'd have, this isn't product rule, but then you'd have a quotient rule on the other side. So I would just leave the answer right here. And then we can check this. So we identified sine theta as our first function. We identified cotangent as our second function. And then we took the derivative of the first function, which is cosine theta times cotangent, so this part is right. the negative cosecant squared theta times sine theta, so this part is right. This comes off to just negative cosecant theta because cosecant theta is equal to 1 over sine theta. So that uses a trig identity and it uses reciprocal rule. It's basically a 1 over x times x is 1 except with trig functions. And then we just got our final answer right here. So this is right. And that is question 3. So for question 4, it's another trig, I believe. So for question number 4, we have y is equal to cosine of theta times cosecant of theta. So similar to the last problem, you can actually simplify this down because we know that cosecant of theta is 1 over sine. So we could say y is equal to cotangent theta, and the derivative of cotangent theta is negative cosecant squared theta. But for the sake of practicing product rule, we will identify this as our first function. And then we know that cosecant theta is our second function. So now that we know that cosine theta is our first function and cosecant theta is our second function, we can just take the derivative. So we know that y prime is equal to the derivative of the first function. So the derivative of cosine theta is negative sine theta times the second function plus, we know that the derivative of cosecant theta is negative cosecant theta times cotangent theta times the first function, which is cosine theta. So if you wanted to, you could rewrite this in terms of sine and cosine. It wouldn't help too much. This part right here does come off to just negative 1 because it's sine times cosecant, and sine times 1 over sine is going to be 1. This other part, however, doesn't really cancel with anything. You could say cosecant, so we can say that cosecant of theta is equal to 1 over sine theta. And then we can say that we have 1 over sine theta times cosine theta. So that gives us cotangent theta. So we can say this other half here is minus cotangent squared theta. And then I guess if you really wanted to, you could factor out a negative 1, and then you could do a trig identity. But I'm just going to leave this here. Then we can check it. We identified cosine theta as our first function. We identified cosecant theta as our second function. Took the derivative of the first function, which is negative sine theta times the second function, plus the derivative of the second function, negative cosecant theta times cotangent theta, times our first function. We use the trig identity to simplify this down. So cosecant is 1 over sine times cosine is cosine over sine, which is cotangent. Cotangent times cotangent is cotangent squared, and this comes off to negative 1. So we have negative 1 minus cotangent squared theta. That's question 4. So for question number 5, we have y is equal to 3 to the x times e to the x. So we know 3 to the x is our first function. And we know that e to the x is our second function. So we can go and apply the product rule to find the derivative. So the derivative of y is equal to the derivative of the first function, which is 3 to the x times the natural log of 3. The reason why it's not just 3 to the x is you rewrite this in terms of e to some power of 3 to the x, so you'd rewrite it as e to the natural log of 3 to the x. And since e to the natural log of something is 1, this would actually be the same as 3 to the x. And then you would say e raised to the x times natural log of 3. And then solving this is a chain rule. So you'd use chain rule here, and you would get 3x times natural log of 3. So that's how you actually find that. Times the second function, which is e to the x, plus the derivative of e to the x is e to the x, times the first function, which is 3 to the x. So we can pull out an e to the x, so we can pull out a 3 to the x. So we can say that y prime is equal to e to the x, 3 to the x, parentheses, natural log of 3, plus, we can only plot an e to the x because, actually, one second, slight mistake here. This should not be times this. This is times here, then plus this. Importance of parentheses. If I plot a 3 to the x here, so this is plus 1. So if you wanted to, this is still a product rule. This is really a triple product rule. The way I probably wrote it in my notes, I just left it how it was before. So I probably left it as 3 to the x times e to the x times natural log of 3 plus e to the x times 3 to the x. Either one works, because if you distribute this back out, you get the same thing. That's just a matter of preference. Since I took the 3 to the x and e to the x out, we'll just say this one's the final answer. But both forms are equivalent. It's just a matter of preference at that point. Although if you wanted to take the next derivative, maybe I would almost just rather do the product rule again on this one, because I have two product rules here. This is another product rule, and then this all comes out to just some number. So I would rather take this one, but again, that's a matter of preference. So we can check this. So we have our first function is 3 to the x. Our second function is e to the x. Derivative of the first function, 3 to the x times the natural log of 3, times the second function, which is e to the x, plus e to the x times 3 to the x. We pulled out an e to the x and a 3 to the x, so that's going to leave us with natural log of 3 plus 1 inside of the parentheses, so that's correct. Now that's question 5. So for our last question, question number 6, it's kind of similar to everything else we've been doing for the most part. So question number 6 is y is equal to the natural log of x times e to the x. So we know the natural log of x is our first function. And we know that e to the x is our second function. So we can just apply the product rule and take the derivative. So y prime will be equal to the derivative of natural log of x is 1 over x. times the second function, which is e to the x, plus the derivative of e to the x is e to the x times natural log of x. So I want to note here that e to the x times the natural log of x doesn't simplify down to anything. So the rules we have for logarithms and exponentials is we have the natural log of e to the x. We can say that's equal to x. And if we have e raised to the natural log of x, we can also say that's equal to x. But we are not allowed to say that e to the x times the natural log of x is equal to 1. That is not valid. So these two work. This one is not valid. And also you can't say e to the x, you can't say e to the x over the natural log of x is equal to 1. That also is not valid. Just to note that. So there's two different ways we can do this. We can just leave it here. We can take out e to the x. So the way I like to write it is I would just leave it. So I'd say e to the x over x plus e to the x times the natural log of x. That's how I would leave it personally. So I would say that this is the final answer. So I don't like doing too many random maths of algebra. If you wanted to pull out the e to the x, you can. So if you pull out e to the x, you would be left with, so let's just do it off to the side here. You'd be left with e to the x times 1 over x plus natural log of x. We know that's equivalent because if we distribute out e to the x, we get the same thing. So as long as you're allowed to use negative exponents, I would, just so it looks a little bit cleaner. So you could say e to the x is e to the x times x to the minus 1 plus natural log of x. So either one, these are both the same. So I prefer this one. You can use this one if you want to. But either one is the right answer. So we can check this. So we identified natural log of x as our first function and e to the x as our second function. Those are properties of logarithms. So we take the derivative of the first function, which is 1 over x, times the second function, which is e to the x, plus the derivative of the second function, which is e to the x, times the first function, natural log of x. I just multiplied it out and just kept it the same, so this one works. This one we pulled out an e to the x, and then we just said it was equal to e to the x times x to the minus 1 plus natural log of x. This also works. I would prefer this on a test because this is a little bit quicker. This one included 2 more steps for me. That's a matter of preference. So in this video we did product rule. The next video I'm probably gonna do is quotient rule and then chain rule, I think. Shout out to my first subscriber, whoever you are. I don't know who you are, but if you have any math video topics or ideas, you can let me know in the comments, and I will try to get around to that as soon as I can. If anybody else has any ideas for future videos, you can also let me know in the comments, and I'll try to get around to it. And all of the notes I went over, and the questions and answers I went over, and the practice questions will be pinned as a comment it'd be pinned as a link in the comment section. So that's product rule. Hope you guys learned something, and I hope you guys have a nice day.